Okay, so in the previous videos we've seen if we have a function f of x equals x square, and you have to find the area under this curve. We use the function. Let's say the second function is g of x equals x cube by 3. So using this function, if you find the change in y between two limits, okay, in this function we actually get the area under the curve of this function x square between the same two limits. Okay, so you've seen that in the previous videos, and this is called the antiderivative of this function, and this is the derivative of that function. Okay, that is clear. Now if I give you another function, let's say I give you this function f of, let's say, some other function which is a of x equals x raised to power 4, let's say. Okay, how do you find the area under this curve? So what you have to find actually first is, so this is also called the indefinite integral of this, right? We've spoken about that also in the previous video. So if I have to find the indefinite integral of this or the antiderivative of this, so what do I think of first of all? Whose derivative is this whole expression? So whose derivative is x raised to power 4, right? So that function will be its antiderivative. So what do I do is, so let us first of all focus on these two functions. When I'm going from here to here, what am I actually doing? I'm increasing the power by 1 and also getting the same power in the denominator here. Okay, that is generally what I can see. So that is a pretty mechanical idea, but yeah, that is important in formulating the power rule of integration. So if I have this function, I can increase the power here also. So I write bx. So this is the integral of this, right? So I'm trying to, if I write these two in the integration notation, okay, so I get integration of integration of f of x. So I write this dot dx, and here I get integration of a of x. So I'm writing the a of x just like I used to write integration of y dot dx. So here y is ax, right? So ax dot dx equals, so here also I can increase the power by 1. I get x raised to power 5 upon, so I get the same power in the denominator, and this is what I get, and this is the antiderivative of this. So if you differentiate this, you should get that. And before doing this, you should even just check that yourself out. Okay, now let me just try this in a general format. So I take a general function y equals x raised to power n. So here also I can simply write integration of y dot dx. So I hope you know this notation. This notation is the same, right? That is the way we write functions. This is simple polynomial, the way we write polynomials. Okay, so integration of y dot dx equals, I increase the power by 1, get the power in the denominator also. Now just to verify if this is the correct power rule, I'll differentiate this expression to get this. So if I differentiate this, I should be able to get this. If I get this, well, then my formula works. So what do I do is, so let me take the function fx equals x raised to power n plus 1 over n plus 1. So f prime of x, the derivative of this thing, equals, so I keep my coefficient. So this is my coefficient here, right? 1 by n plus 1. I keep it as it is. Multiply that by, so now I am solving this part, okay? So here I simply apply my power rule. I get the power in the coefficients place. So this is my power. I'll put brackets here also. And multiply this by x raised to power. So reduce the power by 1. So what is n plus 1 minus 1? Simply n, right? So I get x raised to power n. And now I can cancel these two. So there you go. And what I end up with is x raised to power n only. And that is clearly what is written here. So therefore my power rule is correct. So if I remove all this, this is the formula that you need to keep in mind. Whenever you have something of this form and somebody asks you to integrate this, find the indefinite integral, okay? So the difference between indefinite and definite is only the limits, right? When he gives the limits, it becomes a definite integral. So whenever somebody asks you to find the antiderivative of this thing or the indefinite integral, okay, of this thing, or integrate this simply, okay, what do you use is this formula, something of this format. So this is something you need to keep in mind, and this is because this is dealing with the power here, okay? So this is called the power rule. So that is it for this video, and in the next video we'll learn something more about how to solve integrals. So bye.